Today we will learn factorization by using identities. While learning about algebraic expressions and identities, we have discussed some standard identities. Here, the left side of standard identities is shown. Will you be able to tell their right side? Try it. Let me tell you, do you know, with the help of these identities, we can also find the factors of some expressions. Suppose we want to find the factors of 4x square plus 20x plus 25. Are there any common factors in the three terms of this expression? Think. No, there are no common factors in these three terms. Just think, we can factorize this expression using one of these standard identities. Let me tell you, there are three terms in this expression. There are two terms on the right side of the third standard identity, so we cannot use it. There are three terms on the right side of each of the first and second identity. So, let's understand which identity we can use. We can write 4x square as 2x square and 25 as 5 square. In this way, we see that the first term and the third term in this expression are perfect squares. At the same time, we also see that the sign of the middle term is positive. Can you tell me which of these expressions correspond to the right side of the standard identity? Think. Absolutely right. This expression corresponds to the right side of the identity. A plus b bracket square is equal to a square plus 2ab plus b square. Therefore, we can use this identity. If we assume a is equal to 2x and b is equal to 5, then a square plus 2ab plus b square is equal to 2x square plus 2 multiplied by 2x multiplied by 5 plus 5 square, that is 4x square plus 20x plus 25, which is similar to the given expression. But according to question, a square plus 2ab plus b square is equal to a plus b bracket square, so we can say 4x square plus 20x plus 25 is equal to 2x plus 5 whole square. Thus, with the help of standard identity, we have multiplied this expression, and these are its factors. In this way, to factorize an expression, first we find the identity which has its right side similar to the expression. Then, we find the factors of the desired expression from the corresponding expression on the left side of that standard identity. Now suppose we want to factorize 9y square minus 36y plus 36. Then how will we do this? Think. Absolutely right. Here factor 9 is common in all three terms. So under the distributive property, we can take it outside the bracket like this. We can write the expression written inside the parenthesis like this. In this way, we see that the expression inside this bracket corresponds to the right side of the standard identity, where a is equal to y, b is equal to 2, and 2ab is equal to 2 multiplied by y multiplied by 2, that is 4y. Therefore, we can factorize this expression as y minus 2 whole square. Thus, this gives us the factorization of given expression like this. We can also write it like this. Now, pause the video and find the factors of 49x square minus 100. Let me tell you, We can write 49x square as 7x square and 100 as 10 square. In this way, both terms of this expression are perfect squares. It corresponds to the right side of this identity. A plus b, a minus b is equal to a square minus b square, where a is equal to 7x and b is equal to 10. Therefore, using the third identity, we can factorize the given expression as 7x plus 10 into bracket 7x minus 10. Now, find the factors of the expressions given below. So today we have learned factorization using identities. In the next video, we will see some interesting examples related to them. Today we will see examples of factorization using identities. Factorize the algebraic expression in 3x raised to the power 4 minus 3y raised to the power 4. We see that number 3 is the common factor. From the distributive property of multiplication over subtraction, we can take 3 out of the brackets is equal to 3 into bracket x raised to the power 4 minus y raised to the power 4. Can further factorization be done? Think. Let me tell you, we can write x raised to the power 4 as x square bracket square and y raised to the power 4 as y square bracket square. With this, we can write the expression this way. Now tell me, which identity can we use for factorization of given expression? Pause the video and try it. Let me tell you, we see that the expression written inside the bracket corresponds to the right side, that is, RHS of the third standard identity. Now, we can write it in this way using this standard identity. Again, here we see that the expression x square minus y square corresponds to a square minus b square of the third identity. That's why we can express this expression like this. We cannot factorize the given expression further. That is, we found all the factors of the given expression. Next example. The area of a square is in the form of expression 81k square minus 90k plus 25. What will be the length of a side of that square? We know that the area of square is the square of length of the side. We can write it as length of the side multiplied by length of the side. Looking at this, we can say that the length of side of the square is a factor of the area of that square. To find the length of the side of a square, we have to factorize the given expression. So, let's start. First, we will see if there are any common factors in all the terms of the expression. There are no common factors in all the terms. Now, let's factorize all the terms. The first term is the perfect square. We can write it as 9k square. The third term is also a perfect square, which we can write 5 square. The second term can be written as minus 2 multiplied by 9k multiplied by 5. Observe that the second term is negative. We see that this expression corresponds to the right side of the identity a minus b square is equal to a square minus 2ab plus b square, where a is equal to 9k, b is equal to 5 and 2ab is equal to 2 multiplied by 9k multiplied by 5, that is 90k. Therefore, we can factorize this expression as 9k minus 5 whole square. That is, the length of the side of the square is 9k minus 5. Next example. Factorize the given algebraic expression. 80x raised to the power 4 plus 40x cube y plus 5x square y square. Pause the video and try to find the factors of this expression. Let me tell you. First, we will check if there are any common factors in all three terms of the expression. Here, 5x square is a common factor in all terms. So, we take 5x square outside of the bracket, so we get this expression. Now, we can write the terms present inside the bracket like this. The arrangement inside the bracket corresponds to the right side of a plus b whole square is equal to a square plus 2ab plus b square. So, by taking a is equal to 4x and b is equal to y, we can write the terms inside the bracket as 4x plus y whole square. In this way, the factorization of given expression is 5x square into bracket 4x plus y whole square. Now, with the help of identities, try to factorize 121k square minus 64 by yourself. Today we have seen examples of factorization using identities. In the next video, we will see some mistakes related to them. Today we will see common mistakes related to factorization using identities. Mistake 1. Mistake related to arrangement of terms in algebraic expression. If children are asked to factorize this expression by using identities, then some children get confused after seeing that the terms are not in their standard form and so they could not factorize the expression. We need to arrange the terms in the expression in order to do the factorization. X square and 49 are perfect squares in the given expression. So, we can arrange this expression in this way. Now, we can factorize this with the help of this identity. Thus, we get the result as x minus 7 whole square. Now, will you be able to factorize minus x square plus 25? Try it by yourself. Mistake 2. Mistake in the selection of identities. If some children are asked to factorize algebraic expressions x square minus 6x plus 9, they answer x plus 3 whole square in hurry. But it is a wrong answer. This happens because here children see that 9 is a perfect square and the variable x is also a square. So, they think that identity 1 is used to factorize the algebraic expression shown. They does not notice here that there is a minus sign between x square and 6x. Since the algebraic expression shown has a minus sign between x square and 6x, therefore, identity 2 will be used here. Therefore, the desired factorization of algebraic expression x square minus 6x plus 9 is x minus 3 whole square. Mistake 3. Not using identities a square minus b square is equal to a plus b, a minus b correctly. Some children are unable to use the identity a square minus b square is equal to a plus b, a minus b correctly. They factorize the algebraic expression 9x square minus 36 like this, which is the wrong factorization. Keep in mind that the first term here is 9x square, which is the square of the term 3x. Similarly, the number 36 is the square of 6. In this way, there are a is equal to 3x and b is equal to 6. So, the correct factorization will be 3x plus 6 into bracket 3x minus 6. So, today we have seen common mistakes related to factorization by using identities.